Hello friends, again welcome back to the series of Theory of Computation. My name is Tunisha. This is lecture 2 of module 1. In lecture 1, I have told you about the basic terminology, what is FA, what is DFA. Now in this series, I am covering about NFA. I just take some DFA numerical to just recap what we have taught in the lecture series 1. Okay, so I'll take the problem of divisibility. Like suppose you have a question that you have an alphabet as A comma B, and to make DFA where number of A is divisible by 2. Okay, so in general, how to check that number is divisible by 2? We can take it as 0, 2, 4 or 6, like the thing which is divisible by 2, that gives the answer as 0, means the thing where we divide it by 2, the remainder is 0. So for the TOC, if I'm talking about the null, that means null string. For 2, that is 2A. For 4, that is 4A. For 6, it should be like 6A, right? So how to make a DFA? DFA means you should start with the null string and then give two string, then you reach from initial to the final state. After giving these two A, after giving 4A, you also reach from initial to the final. That means something like if you have a initial state as Q naught, how to make a DFA for null string? To make your initial as your final, right? For final, to now what we have do, we just take 1A and then after 1A we reach to the final state, like, right? This is something which is divisible by 2, means the number of A is divisible by 2. Now what about the B? Like how to make a transition of B? In this numerical, is we care about the number of B? No. Like how many times we occur, we doesn't care. Either it should be occur like this or it should be occur like this. We only care about the number of A is divisible by 2, right? So we can make a transition like B and B. Now, for this, your task is like you have to check your task is to make for the divisibility by 2. Okay. So for this is your task to make a DFA for checking the number is divisible by 3. Now I'm taking, and suppose this is the case where the input alphabet is A and B and we check the number of A is divisible by 2. But what about the series? Suppose I'm giving a question like you have a alphabet 0, comma 1 where you make a DFA where binary string is divisible by 2. Like we have to check for the binary string. Divisible by, here we can take divisible by 3. Okay. So there is a trick to solve that question. Like I have told you how to make a table. In this, we take a alphabet as 0 and 1. Now we are checking the divisible by 3. That means we have to take a 3 step as the Q0, Q1 and Q2, right? So we take a step as initial state Q0, Q1 and Q2. Okay. So how to make that table? You just simply write like Q0, Q1, Q2. Again repeat Q0, Q1, Q2. From this table, if you make a DFA, then this is right. This is a simple way to check that the binary string is divisible by 3 or not. Okay, if there is a alphabet like 0, 1, 2, and you have to check the divisibility by 3, then this is the way same as the we have done before. The alphabet is like 0, 1, 2, that is Q0, Q0, Q1, Q2, then again Q0, then again Q1, that is Q0, Q1, Q2, then Q2, Q0, Q1, Q2. Okay, if you make the table from this table, then this is also good. So this is the trick to solve the divisibility problem of any string. Okay, so this is all about some numerical. If you want some more numerical, you can telegram me. You can ping on telegram. I will definitely share you a question book regarding the DFA which have asked in the GATE syllabus. So now I move to the next topic, that is about the NFA. NFA means I have told you and shows like non-deterministic. Non-deterministic means we doesn't know where. Suppose in the DFA, if I'm giving a Q naught and give a transition of A, then there is simply a one state. There is no other choice for a transition A. But if I'm talking about the non-deterministic means we have a state Q naught, we have a transition A, but we doesn't know where to go. There are many options available to go for a transition A. There are many options available. So this thing is known as the non-deterministic. Means we are not capable to determine that from the state. If I'm giving a transition A, then which state is going to be choose next. Okay. So simply the tuples are same as I have defined in the time of DFA. The tuple is NFA, that means Q, sigma, transition, Q naught and F. Q is for, now class, you are good to answer that question. Q is set of finite state. Okay, this is your input alphabet. This is your transition function. Now in the NFA, transition function is different from the DFA. Like the transition function is Q to the power Q. Because 2 to the power Q is just because we are not confident that where we have to go from the state if I'm giving some transition. That's why this multiple choices are available. So it is 2 to the power Q. This is for start and this is for your final. So the states are, the tuples are same as in NFA. NFA, DFA, both our tuples are same, but the only difference is the transition function. Okay, class? Now, I'll just take some example of NFA, that how to make an NFA if you were asked about this. Okay. So, could you make, so I'll take some example like draw a NFA that accept the substring as 0, 1 over an alphabet 0, 1. Okay, then how to make it? Like substring is 0, 0. The minimal string is 0, 0, 0, 1. The minimum string is 0, 1. This is the answer. So the minimum string is 0, 1. Now, if now we fix the position of 0, 1, we don't care about the initial, we don't care about the final, right? It should be like, it can be like 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. We don't care. We just fix the position of 0, 1. That means we have to make firstly for 0, 1. That means 0, then is for 1. Okay, this is their initial state, this is their final state. Now, what do we want? We doesn't care about anything in the beginning and anything in the last. Okay, so you have a thought in your mind that what is the difference between NFA and DFA, right? So I'll just give you some difference. Like if I'm making a DFA for the same problem, then there is a restriction that we have to make a transition of 0 at Q1. This is a restriction in the DFA. But if we are talking about NFA, then there's no restriction that you have to make a transition of all input alphabet. Okay, so this is very much simple as compared to the NFA, because there is no restriction to make a transition of all input alphabets, right? So, but now the main difference which I want to show you, like there is a two transition for 0. Either we can go to Q0 or we can go to the Q1, right? Means if I am giving a Q0 0, then there is a choice. I'm itself in a Q0 state, or I can shift to the Q1 state, right? So this is all about 2 to the power Q. Why I'm writing 2 to the power Q as a transition function. Okay, so you can also make NFA for the problems, for many problems. It is very simple to make this. Okay, so if I'll make another lecture for the questions of NFA and DFA and how to solve. Okay, here I'm just covering the tricks and techniques which is helpful to solve the problem. Okay, class. Now I just take another topic, which is conversion from NFA to DFA. Like this question is sometimes is asked that how to at the time when the paper is coming, there is something showing like you have to make a DFA, you have to find a minimum state in a DFA, but but you are capable to make a NFA, right? So how to change from NFA to DFA? There is algorithm present. Means we have a NFA, we want to convert it to the DFA. In the NFA, the tuple should be like Q naught Q bar Q. The tuple should be the same as Q, sigma, Q naught and F. In the DFA, it is also Q, sigma, Q naught and F, right? So I'll take some question which is going to show you that how to change from NFA to DFA. Okay, the question something like, if you have A, B, then okay, this is NFA. Now how to change it to DFA? Simple way, make a transition table of NFA. A, then B, then take A and B. A, we can go to A and B. Like if I'm taking A as a transition on the capital A state, then there are two choices. Either we can go to the itself or we can go to the B state, right? So and for the transition B, we simply go to the A state. Now for the B means if I am giving A, B itself is in B and B, right? Now we have to make a table for DFA. I'm not writing any theory for this. I'm just giving a trick to solve this problem from NFA to the DFA. Okay. The trick is simply write this symbol as NFA. Now start with the initial state. Initial state is always same in both NFA and DFA, right? From the initial state, the transition you just copy from first row of NFA to the first row of DFA. Just copy. Right. Now here we try to you have to try find out the new state which is not present in the previous. Okay. So the new state is A comma B. Take it as a one state. Take it as a one state. Okay. So at that state, if I am giving a transition A on A, I am giving a transition A on A, we can go to A or B. Right? If I am taking a B and B giving a transition A, then we reach to B and B itself covered in this. Okay, so we didn't write to here. Now take another. If I am giving a B, we can reach to A and we can reach to B. Okay, class. Right? Is there any new state remaining in the DFA table? This is NFA table and this is DFA table. Is there any new state remaining in this? No. So the DFA table is constructed. Now I just quickly repeat that the question is to change from NFA to a DFA. You have a NFA diagram. You just make a table for that NFA and try to make a table of DFA. In the DF, if you want to make a DFA table, just the first thing is to the alphabet is same as in NFA. Start from the initial state, copy the first row to the DFA table. In the DFA table, try to find is there any new state? Yes. A comma B is the new state for me. For the new state of A comma B, if I am giving a transition, small a transition on capital A state, then we reach to capital A comma capital B. Try to just put this into the column of A. And then again, if I am giving B to A to B state, then we reach to B. B and B are same, so we just take A comma B for the transition of A whole. Same with the B. So, is there any new state remaining? No. Repeat the process until you reach to the same state. Like if you have a new state, you have to make that same state as a state table in the state column, and then make a transition to take this. Okay. So if I'm making a DFA for that, then it's simply I'll take A as an initial state, AB as a single state. Okay. For this, A, B, then A comma B. Now there is a confusion which is the final state, right? So the final state of B is the final state of NFA is B. In the DFA, the state which covered the B as itself is known as final state. So this is the final state. Okay, class. So this is the way to change from NFA to the DFA. Okay. Now I'm taking another example also. Another example is small a you have a transition on capital A, B, then B, then A comma B, and then C. Okay. Make an NFA table. Is the input alphabet is AB. The initial state is capital A. If I'm taking capital A, if A transition is occurred, then we reach to either A or B. Right? For B, we can reach to A. Now taking B as a state. For at the B, if the transition is A, then we reach to C. Right? And at the B, we reach same as C. Now taking C as a state. In the C, if I'm taking a A, we reach to null. Means we didn't have any transition at the state of C, right? But we have to mention this state because in the at the time of conversion from NFA to DFA, you have to take a single state. If you have a transition, that is well and good. If you didn't have any transition, then you have to mention the null sign. That means 5 कि हम यहाँ से अब कहीं नहीं जा सकते. Okay. Now conversion from NFA to DFA. Start. DFA. Small a, small b. Copy the first row. As I told you, copy the first row. A comma B, then A. Now take this step as a new state. Now from A, check it to the NFA table. From A, if I am giving A, we reach to capital A, capital B. And if I am taking B, then we reach to C. For A, check to this row. For B, check to this row. Right? Now for A, if I'm taking B, small b, then we reach to A and then C. Is there any new state? Yes, there is 2 new state. First, pick anyone from there. Pick anyone. So I'll pick A, B, C. Now check for A in a A row, check for B in a B row, and check for C in a third row. Now we reach to A, B, C. Same with AC. Now the another new state is remaining, so mention AC. Check for A, where to reach after giving a symbol. Is it AB? Then A. Now is there any new state remaining in that table? No, we just covered all the state like AB, ABC, AC. So there is no state. Now take this column as a states. Suppose A as the initial, then AB. Okay, now take A, B, C, then take A, comma C. Now which state is final? The same thing which I have done in the previous example. The state which is final in the NFA, the same state is final in the DFA. Means that where the C is covered in that state, this is known as the final state. Now just make a transition as in table. So this transition is same. So this is DFA for the given question of NFA. Okay. So this is the way to change from NFA to DFA. This is a simple way. Okay, class. So I can assume that you are good enough to understand what is DFA, what is NFA. Now the next topic is null NFA. Null NFA. Null NFA also same as NFA. It has the same tuple as Q, sigma, transition function, Q naught, and F. You all are very capable to know about these terms. But the only difference in the null NFA and NFA is transition function. In the null NFA, the transition function should be like union of null string. That tends to null. The difference is we add a null to the input alphabet. To the input alphabet, we add null. Okay, this is the difference of NFA to null NFA. Okay, like so in the null NFA, we have some transition, some which looks like this. That is Q naught, and that is Q2. Okay, so this is the same way we have did, like the difference in NFA and null NFA is that there is something a transition for the null also. Like for the null transition, we reach from some state to the another state. It may be here also. It's depend upon the question, like how to solve this. So this is null NFA. Now the main topic is how to change from null NFA to the NFA. Right? We have already learned about how to convert from NFA to DFA. Now change from NFA to the null NFA. Suppose you have a question like A is the transition, X, you have another state as B, and there's a transition like B, and there's null state. Okay. So how to convert this null NFA to the NFA? I will tell you the technique, and I will tell you the process. Okay, how to change from null NFA to the NFA. For converting null NFA to DFA, NFA, the main first step is to calculate the null closure. Now, what is null closure? Null closure is the term like if I am calculating the null closure of A state. Calculate null closure of all states. So first, suppose I am calculating the null closure of A state. Null closure of A state means the state which I have taken for the null closure, it includes itself first. Then check it the NFA, null NFA diagram that from that state where to reach at the time of null transition. Suppose in the A state, if I am giving the null transition, we reach to the B state, right? So in the null closure of A, B also included. Now suppose I am checking the null closure of B. So null closure of B is only the itself, because there is no transition of null from B to some other state. Okay, class. So I think you are very good to calculate the null closure. Suppose I'll take some another example. A, null, then B, then null. Now how to calculate the null closure of this? So null closure of A is A itself, then B. When I am giving a null closure at the A state, we reach to the B state. But here also a null closure. Null closure means we also can reach from A to C. So C also included in this. नल क्लोजर का मतलब होता है हमने ए स्टेट पे अगर कोई नल ट्रांजिशन दिया है तो हम किस स्टेट में पहुंच रहे हैं, क्या उस स्टेट पे भी एक नल ट्रांजिशन है। अगर नल ट्रांजिशन है, नल का मतलब होता है वो कुछ नहीं है, कुछ नहीं का मतलब ए से हम सी पे भी जंप कर सकते हैं डायरेक्टली। क्लियर? तो नल क्लोजर ऑफ ए इज null closure of A is something like that. If I am calculating null closure of B, then null closure of B is B itself, and then where we reach from B to C at the time of null closure is C. Null closure of C is C, only C, right? So this is the way to calculate the null closure of anything. Now move to the question. I'll just this is just for to better understand the null closure. Now move to the main question. Main question is something like the first step to calculate the null closure, right? So if we are able to calculate the null closure, then make a transition table. Make a transition table. There is an input alphabet is x comma y. There is input alphabet as x comma y. So the second step is to take in the state of A in the state of A, the x is defined but the y is not defined. So we check for the ax and y both for the state of A. So the formula is null closure of null closure of A comma x. Okay, so null closure of A is A comma B comma x. If I'm giving x the same as this statement is the same. Now if I'm taking A as state and giving the transition x, we reach to A state. If in the B we didn't go to any state, that means the simply is A. That means null closure or of A. That answer should be A comma B. Means for the state of A, if I am calculating x, that means we reach to either A state or B state. Okay, at the time of transition x, we reach to either A state or B state. Now second, for the transition of y, the formula is same, null closure, then null closure of the state which I am taking, comma y. Now check for the y. Null closure for y. Move to the previous slide. If I am giving y transition at b, we reach to y. That means simply here is b. So null closure of b is b. So b. That means if I am giving a y transition on a state, we reach to b. So null transition means we just calculate the transition for the state where the null transition start. So here is only the A state where the null transition start. We have to calculate only for the A state for both transition. So diagram is the before diagram is before calculating the null closure, the diagram should be like this, right? But after calculating the null closure, if I am giving x on A, we reach to A or B. That means A and B. For giving a Y transition on A state, we reach to B. Right? So this is the NFA from null NFA. This is the NFA from the null NFA. I'll just repeat the whole process. Like firstly, you have a question that is something have a null transition in that, and you are supposed to ask about to convert it NFA. Then the simple process is that you just take null closure of all state. Null closure, how to calculate null closure? I have told you that can include the state itself and then add the more state from where to reach at the time of giving the null transition. Okay. After calculating the null closure of all state, just calculate the transition from where the null transition start. Here is only the one null transition start from A, so we have to calculate the transition for X and Y on the state of A. At giving the transition X on state A, we reach from, this is the formula, like, and firstly we have to write the null closure, then again null closure of that state comma transition. Taking the null closure of A as AB comma X, calculate from where to reach from A after giving the transition X, from where to reach from B. So here simply we reach to A state, then the null closure of A is simply A and B. That means if I am giving a transition X on A, we reach A and B both. We just include the transition as A and B both. Right? So now the main important thing is here that which state should be a final. So the state where we calculate the null transition, if it consists both state, then the both state should be a final state. For which okay class, so for which we calculate the transition for A state, it include both as a final state. So this is the way to convert from null NFA to NFA. If you have any doubt, you can ask me simply by telegram that what is the next what is the that what is your doubt, so you can ask simply on telegram. If you want more question, you can also ask me on telegram, so I will share a PDF for question of these. So this is all about the series. This is all about the series of NFA, conversion from NFA to DFA, and what is null NFA, how to change from null NFA to NFA. If you have a question, something like you have to check from null NFA to DFA, then how can you change? You just take null NFA, then change to NFA, then change to DFA. I have told you the process how to change from NFA to DFA and null NFA to NFA. Okay, class. So this is all about the NFA series. If you like my video, then subscribe the channel and hit the like. Thank you, class.